Okay, you guys, I am going to walk you through it's this packet here. So BP3 packet. I don't know if I know how to zoom it. Let me practice. Hold on. Let's see. Let me zoom this in quick. But it's a BP3 packet, and I'm going to walk you through the very last activity of this packet. So in here, if you will turn, first of all, page 5, if you did the directions correctly that was on Google Classroom, you were told to do some estimating. So we're going to be looking at these 6 different objects. Here's a wood block. So wood block happens to be made out of aspen. Let me make this a little less bright so you can see. We're going to look at a matchbox car. Get this on a piece of paper. There you go. So we're going to look at a matchbox car. We're going to try and find the density of water and then the density of oil. And then we're going to take the density of this piece of clay, and then we're going to take it in half, literally break it in half, and find the density of a half a piece of clay. Okay, just 1/2 of those. So before you ever start, we want you to do some guesstimating. So on here, we want you to estimate which of these items you think is going to be the most dense. So they're listed there again: the wooden block, the water, the oil, the matchbox car, whole piece of clay or half a piece of clay. Which one do you think will be the least dense? And then try to explain why. And then I want you to brainstorm what tools. So think of the typical tools we've used to collect volume. We've done things like this before. We've used a ruler to collect volume. Scales are things that we've used. So what tools are you going to need to accurately collect the density? If you were to ask to do the density of these different things, what would you need? And then what type of method are you going to use? So are you using displacement, water displacement to find volume? Are you using just measurements of mass and then length with the ruler? So length, width, and height. So that's what it means for method. Is it going to be volume by displacement or volume by metric measurement? How are you going to find mass? Mass by using something besides a scale, or are you going to use a scale? Okay, so I want you to first fill out this entire page, all of page 5, and then you're going to hit pause, and then we're going to make these calculations together. All right? So hit pause. We'll come back in a little bit. Okay, so hopefully you have done that first set of directions. I'm going to start with the wood block here. So if you keep looking, and I'm just going to zoom in a little bit again for you. All right, there we go. So I'm going to begin with the scale, and we're going to turn it on. We're going to 0 it. And we are going to put this wooden block on here. So placing the wooden block on, if we look at the mass, that says 21, and I think we'll say 21.6 grams. So I want to transfer that 21.6 grams onto my sheet of paper by the wooden block. So mass 21.6 grams. Okay, to find volume of this, this is a regular shaped object, so we could probably use a ruler for volume. So I'm going to give you some length, width, and height measurements. So it looks like we're going to go with a 4.5 centimeters. So I'm just going to write this down. Then this measurement looks like about 5.7 centimeters. And then I have to do a height or a width measurement that looks like about 1.9 centimeters. Okay, so that number is going to go, and I'm going to have you guys do your math on your own, but 4.5 by, I got to look at it again, 5.7 by, it was 1.9, I believe, 1.9 centimeters. Okay, you guys can zoom in yourselves too if for some reason you're not seeing this well enough, and you can give me feedback later. Okay, that if I need to make some improvements, it's the only way I'm going to get better at this is you guys giving feedback. So you can come up with your own volume measurement, length times width times height. Remember, your answer will be centimeters cubed. And then I want you to calculate that density as well. 21.6 divided by this number. And remember, this answer is going to be in grams per centimeter cubed, whatever number you get there. Okay, so now let's move on to the water. So I am going to go back to the scale, and if you kind of see me over here, I'll get you to the sink, but I'm going to fill up a little bit of water here. And we're going to the balance. I'm going to put this empty cup on here. I'm going to zero it out. So we'll hit 0. And I'm going to pour, doesn't really matter. We're just going to pour some amounts in here. Oops, but I know the size of my graduated cylinder. Okay, so that'll probably work well. We're going to go with that mass right there. So 35.2 grams is our mass of the water. So we go back to our sheet for the water here. We're going to write in 35.2 grams. And now for volume, I am going to use this graduated cylinder, right? Somebody uses graduated cylinder. Pour that in there. So pay attention to what I got going on here. Okay, graduated cylinder. Let me get you a reading for this. And I would say it is 35, a little over 35. So maybe we say like 35.1 milliliters. Okay, but my rough estimate, I'm going to say 35.1 milliliters. So again, you'll do the math. And once you do the math, we're going to have a gram per milliliter. Okay, now it's going to get a little messy. We're going to do the same idea, but with oil. Okay, so I went and I bought some vegetable oil. You see that right here. And we're going to find the density of vegetable oil just by collecting its mass and its volume. So I'm going to just pour a little bit out into this cup. Okay, we're going to do the same concept. Move my scale back over here. All right, we're going to actually put the cup on it first, like what you saw me do. And I'm going to hit 0. Okay, and it is already zeroed with that on it. And I'm going to pour this oil in here, and we're going to get a mass reading. And it looks like that's 43.7 grams for our oil. So let's go ahead and put that in for the oil mass, 43.7. Okay, so right here, 43.7 grams. And now we're going to put that also in this graduated cylinder. Obviously, I want to pour the water out first. I'm going to pour that out in the sink. And I'm going to put this oil in here, and we're going to get a volume reading. Okay, so again, graduated cylinder, I'm going to read at the bottom of that little film, the bottom of the meniscus, see what we end up with. And I would say that it looks like we have a 40. 1, 2, 3, 4, 5. I would say 46 milliliters. 46 milliliters is probably a pretty good number here. So we'll write in 46 mils. And again, for this part, mass divided by volume. So we'll get grams per milliliter. Okay, let me do just a little bit of cleanup here. And I'm going to let that get rinsed out in the sink some. And while that's happening, we're going to move on to the Matchbox card. Okay, so now this is the first time that, well, the other two we were dealing with a liquid. Now we're dealing with a irregular shaped object. So it won't be different with how we collect the mass. I'm just going to re-zero this, and we'll place this on the scale. We'll get ourselves a mass of this guy. And it looks like we have 36.4 grams. So let's put that here, 36.4 grams. But if you remember, and I'm going to have you travel a little bit over this way with hopefully not breaking too much. Okay, so take a look at the sink and what we're doing here. All right, we're going to go to this overflow can. So remember how we use this thing right here, the overflow can, to get a volume of an irregular shape? We're going to fill it up as much as we can. So this method we're going to use displacement for. And I'm going to just set it there on the side. I'm going to let the water, hopefully you guys can see that, but the water's slowly draining out of that. Kind of cleaned out this match or the graduated cylinder. Coming over here to get the car, and I'm going to put the car in the beaker, or my overflow can. I'm going to put the car in there, and I'm going to collect the volume, the water that it pushes out. I'm going to collect that volume in the graduated cylinder, and then we're going to read it. Okay? Looks like the water's moving in there just a little bit. Okay, I think I'm going to go for it. All right, so the Matchbox car, this only works if it sinks. Now, it sinks, so that should let us know whatever mass we come up with hopefully is going to be, or density we come up with is hopefully a density greater than 1, right? Because it's sunk in water. So that's probably a pretty, it might be dripping a little bit more, but we'll be okay with that. So I've got 10 mils, 11, 12. It looks like I've got 13 mils. So we're going to get back over here with our paper. Okay, hopefully I'm not making you too dizzy. And we'll write 13 mils on this sheet of paper. Okay, and again, you guys are going to do your own calculation, see what you come up with. Now we've got the whole piece of clay that we want to do next. So I'm going back to my scale. I want to make sure it's zeroed. It is. And there's some little piece of white clay in here, if you see it, but I'm not going to worry about that. It'll be okay. So let's put that on here. We'll get a mass. And it looks like I've got 22.3 grams. So this is my whole piece. 22.3 grams. And, you know, I could take time to maybe shape this into some type of a regular shape. But, in fact, for now, well, no, we'll come back. Sorry. I was thinking maybe I could get the mass of the half, but we can't. We'll just do it 2 separate times. Okay, so we're going to do the same idea. Oops, get the Matchbox car out of here. Except we're going to do this for the whole piece of clay. See what we end up with. Then we'll do it again for the half a piece of clay. Okay, so see what I've done here? Just the exact same setup as before. I'm going to put my lid on my oil while I'm waiting for that to get done. And I know you can't see all of me, but that's not the important part. Okay, and let's get you a little closer in case you're wondering exactly what's going on here. So remember, this clay is going to go in here. By displacement, we're going to collect whatever is extra into this graduated cylinder. All right, so that's what's happening up close here. Okay, so I'll put this in, and then we're going to collect what's overflowing and make a volume reading here. It's still dripping a little bit. We'll call that good. And we have 10, 11, 12, 13, 14, about 15 mils of water that's in here. So let's write 15 mils for coming back around here for this piece. So 15 mils. And then that again is a gram per milliliter reading. And now we're going to take that piece of clay and we're just going to break it in half. So let me go ahead and get this set up for the next round while we get a new mass. Okay, so I'm taking this piece of clay and I'm just going to break it in half, and we're going to do half a piece of clay and see if that makes any change. So if we look at our new mass for this, well, we know the mass is going to be different, right? And we know the volume is going to be different too. We're just wondering how different. So we have a new mass of 11.4. So we want to write that in here. Okay, our new mass of a half a piece is 11.4 grams. Now let's take this over, and this is the last thing we want to find the density of. And we're going to that overflow can again. Now, while we were getting the mass, we already have filled this up, so it's probably pretty ready for us to put it in and collect what this half a piece of clay might do. Holy Moses. Did I really fill it up all the way? Hold on, you guys. Even a science teacher messes up like this. All right, let's let that kind of stream out of here and see what we end up with. Sometimes we can have something with such a small volume that these overflow cans won't collect it, but I hope that's not the case this time. All right, I'm going to be a little impatient. Perfection would be me waiting for it to completely stop dripping. But let's see what we get here. Oh, there we go. So again, this is collecting volume by displacement because volume is irregular. And let's see what we get with this volume. And again, I'm being a little impatient. You guys would have done a great job waiting longer, but it looks like I've got less than 10 mils. I would call this about, I would say 9 mils, maybe even 8 mils, but we'll go with 9 and see what we come up with that number. And I might actually, you know what? It probably was closer to 8. Let's actually hit 8 on this one just because I think we had some oil that was there making a bubble. So let's put 8 mils right here. Okay. And then that answer is also going to be in grams per mil. Okay, so that's this piece. Now, over here, on this side, it says if the density of an object is greater than 1, it should do what in water? That's on my, look how wet my lab sheet is. And then if the density is less than 1, what should it do? We are about to travel over to the fish tank, and we're going to drop all of these objects in the fish tank. And we're going to look at what we calculated, what we think it should have done. So based on our calculations, it should have sunk or it should have floated. We're going to look at what it actually did do. And that's what you'll write here in this column. Did it sink? Did it float? What happened? And was my claim density supported by the fish tank dunk evidence? Yes or no? Okay, so we're going to do this, and then you'll eventually, for homework, you do have a good amount of homework tonight. You're going to finish these questions that go with this activity, but then do all of this density practice. So there's density calculation practice on this page and then the following. Okay, but let's actually travel over to the fish tank, and we are going to do, I am even going to pour a little bit of oil in there, and we're going to watch what happens when we find my Matchbox car. Okay, and you're going to lose a portion of the screen, I think. Oops, you weren't supposed to lose the whole screen, but there we go. Okay, so now let's go over here. All right, and let me just move this down a little bit so you can see. So I still have the Coke, and I got the Diet Coke in there from, I'm going to put this a little bit lower. Sorry, you guys. Okay, so this is the Coke and the Diet Coke that we had in there from before. Hopefully you guys can see Diet Coke is floating less than 1. The regular Coke is sinking. So I'm going to put the wooden block in first. Now, based off of what this does, this is going to let you justify if your calculations were correct or not. Okay, let me get all that craziness out there. All right, so here we go. Wooden block. It is definitely floating there on top, right? So hopefully when you did your calculations, you ended up with a density that's less than 1. If you didn't, then something might be off with your calculations. So go back and check. Okay, let's try. I know I'm not doing it in order, but that's okay. Let's do the Matchbox card next. So based off of your calculations, what did you expect? Fill that out first, and then let's see what actually happened. So here we go, Matchbox card. Oh, Oh, she sunk. She sunk all the way down to the bottom very quickly. All right, so hopefully your calculation was greater than 1 for that. Should we do some oil? It's gonna be kind of gross, you guys. All right, watch carefully. I'm gonna try to like mastermind holding this and you watching. So here we go, pouring the oil in. Ooh, look. It went down, but what's it doing now? Rising up to the top. Why is that? Its density is less than the number 1, right? It's less dense than water. Who's going to clean that out for me now? Okay, what about, I got to go back and get the other piece of clay. Hold on. Okay, so here's a piece of clay. We're going to put this in, and then I'll take it back out and I'll tear it in half, and we'll put that in, see what happens. So based on your calculations, hopefully you've already filled out what you think is supposed to happen. Now let's see if it does. Aha, look what it did. It's way down there at the bottom. So a whole piece of clay sunk. Hopefully you calculated something greater than 1. And I'm going to reach in here. Wow, that's disgusting. And we're going to go with a half a piece of clay. So I'm going to keep 1 out, put 1 in. It did not. And that's what you guys should see. It's still sunk. A half a piece of clay. Oh, now I see what I'm doing. Half a piece of clay does not change its density. Sorry. And I can't like fix this right away because I got oil all over my hands. This is why science teachers need a new Chromebook every year, probably. All right. So that's your lesson on density with the lab activity that we were supposed to do. Finish the questions on that page. And then finish the rest of the packet. Do all of the density calculations that are there. The next page, there's some more density calculations. Check your answers. We're going to take a quiz. Can't remember what day right now. I think that's on Friday that you're going to do the quiz. And we're getting ready for a test over everything by next week. Okay? So we'll see you soon. I'll check back with you in a little bit with any questions that you might have. Take care, you guys.